Okay, now we are going to move on to multiplication of matrices. Okay, multiplication involving matrices. Okay, so for a start, we're going to start with this thing called the scalar quantity multiplied to a matrix. Okay, scalar quantity means a number. Okay, so when we want to find a product of a number with a matrix, okay, this is still pretty simple. When you want to multiply a real number k to a matrix, right? You're just simply going to multiply the number k to each of the elements in the matrix. Okay, so let's say in general, you have matrix A, right? With all of these elements. Then you're going to just multiply k to each of these entries so that you have ka, kb, kc, and kd. Okay, so that's for scalar multiplication of a matrix. So let's say, for example, if you are given something like that, 2 multiplied 2, 1, 0, 3, 4. Okay, so this is not a matrix. When you don't see a bracket, right? This is a scalar, or what we call a number. Okay, so then you should utilize this scalar product of a matrix. So this is just 2 times 1, 2 times 3, 2 times 0, and 2 times 4. Okay, so this should be equals to 2, 0, 6, and 8. Okay, so that's for scalar multiplication. Okay, now for multiplication of matrices. Okay, this is the key one that is a bit more confusing. Okay, so first of all, when we want to multiply two matrices, right, it's different from addition and subtraction. When we talk about addition and subtraction, right, the matrix or the matrices should be of the same order. Okay, but then for multiplication of two matrices, okay, so you're going to multiply two matrices together, they should have this condition, okay, when the number of column in the first matrix is equal to the number of rows in the second matrix. So how do you see this simply? Let's look at this example over here. Okay, so every time before you do a matrix multiplication, write down the order of each of the matrices first. Okay, so let's say if you're going to multiply this by this. Okay, so first of all, this is a 2 by 2 matrix, and this is a 2 by 1. Okay, so if you see the ones in the middle matches up, right? Okay, so this 2, which is the column of the first matrix versus the row of the second matrix. Okay, if they are of the same number, then you can do matrix multiplication on these two matrices. Okay, then this and this will be the resulting outcome of the order of your matrix. Okay, the outcome matrix. So in this case, right, if you're going to multiply these two matrices together, you're going to get a 2 by 1 matrix. Okay? Okay, so how are you going to do this then when you do matrix multiplication? Okay, so here, first, start with first row and the first column. Okay, so you're going to take 1 multiplied to 1 plus 2 multiplied to 2. Okay, and then row 1 and column 1 will give you this row 1, column 1 entry. Okay, then when you look at row 2, multiply to column 1. Okay, you only have one column in this case. So these will give you the row 2, column 1 entry. Okay, so you will take 3 multiplied to 1 plus 4 multiplied to 2. Okay, then you're going to simplify this to be 1 plus 4 and 3 plus 8 at the bottom. And then hence, this is going to give you your 5, 11. Okay, so this is your 2 by 1 matrix. Okay, now let's do another example together. Okay, so first check. This is a 2 by 2 matrix, and this is a 2 by 2. Okay, so this matches with this, right? So therefore, your outcome would then be a 2 by 2 matrix. Okay, so you're going to look at these and this. Okay, so now you have confirmed you can multiply this, right? Okay, then now let's look at where will your 2 by 2 matrix look like. Okay, so you are going to look at these and this first. Okay, the first row and the first column. Okay, so first row, first column will give you this first row, first column entry. So 2 times 1 plus 1 times 2. Okay, then now you're going to look at first row, second column. Okay, first row, second column is going to give you the first row, second column entry of your outcome matrix. Okay, so 2 times 2 plus 1 times 1. Okay, now let's move on to the second row and first column. Okay, so second row, first column is going to give you the second row, first column entry here. Okay, so again, multiply 0 to 1 plus 3 times 2. Okay, then lastly, second row, second column. Okay, so your last entry over here, second row, second column. Okay, then this is going to be the entry 0 times 2 plus 3 times 1. Okay, then you're going to get 4, 6, 5, and 3. Okay, so again, your outcome is a 2 by 2 matrix. Okay? Okay, now this part over here. Okay, remember from the start, right? We have identified what is an identity matrix. Right? Okay, so what is the use of an identity matrix? So recall your identity matrix should be a square matrix, right? Firstly, okay, where the leading diagonals okay, the elements should be equals to 1. Okay, so that is what we call an identity matrix. So first, if you have A, which is a square matrix of order n times n, and I is the identity matrix of the same order. Okay, then when you multiply, okay, when you do matrix multiplication of A to I, this is the same as I to A, and this will give you back the original square matrix A. Okay, so let's look at this example over here. So let's say if you have matrix A, that is this square matrix. Okay, so must be square matrix, first of all. Okay, then when you multiply to an identity matrix, okay, the identity matrix can only be 2 by 2, okay, because when you do multiplication, right, matrix multiplication, first of all, they should match, right? So if this is a 2 by 2, then your identity matrix can only be also 2 by 2, okay, because your identity matrix must be a square matrix also, right? So if this is a 2, then this should also be a 2. Okay, then your ultimate outcome will also be a 2 by 2 matrix. Okay, so when you do matrix multiplication, you have this multiplied to this. So you have 2 times 1 plus 1 times 0, which gives you 2 here. Okay, then when you multiply this to this entry, you have 2 times 0 plus 1 times 1. So you get a 1 here. Okay, then now if you deal with the second row, first column, you would have 0 times 1 plus 3 times 0, which gives you 0. Okay, then lastly, this and this. You have 0 times 0 plus 3 times 1, which gives you your 3 over here. Okay, then what you realize, this is basically your A, right? Okay, so therefore, any square matrix, okay, of the same order as the identity matrix, right, will give you back the original matrix. Okay, so that's the use of our identity matrix. Okay, now let's do a few matrix multiplication examples. Okay, so let's look at the first one. Okay, again, before you do matrix multiplication, always identify the order first to see whether it's possible to do. Okay, so this is a 1 by 2 and this is a 2 by 2. Okay, so you realize the middle here matches, right? Okay, so this is possible and your outcome would be a 1 by 2 matrix. Okay, so this is a 1 by 2 matrix. Okay, now let's start to do this. So row 1, column 1 entry. Okay, so row 1, column 1 entry, you take 1 times 1 plus 2 times 3. Okay, then now row 1, column 2 entry. Okay, so still at row 1 and at column 2. So 1 times -1 plus 2 times 0. Okay, so this should be a 1 by 2 matrix. So this will give you 7 and 1. Okay, now for this one, again, check this is a 2 by 2 and this is a 2 by 1. Okay, so the middle matches, right? So your outcome is a 2 by 1 matrix. Okay, so over here, this should be 2 rows and 1 column. Okay, now let's do step by step. So this and this one first. Okay, so row 1, column 1. What is the entry for row 1, column 1? So you have 1 times 4 plus -1 times 1. Okay, then next, you have row 2, column 1. Okay, so the entry in row 2, column 1 will then be 0 times 4 plus 2 times 1. Okay, then this gives you 3, 2. Okay, so this is a 2 by 1 matrix. Okay, then this was a 1 by 2 matrix. Okay, now let's look at this one. Okay, so this is a 3 by 1. This is a 1 by 3. Okay, so the middle matches, right? Your outcome would be a 3 by 3 matrix. Okay, so how would we see this 3 by 3 matrix? Okay, so first of all, okay, locate row number 1. Okay, row 1, column 1. Okay, so row 1, column 1 entry will give you 4 times 5. Okay, then row 1, column 2. So row 1, column 2 entry. Okay, then against that row 1, column 3. Okay, so 4 times -2. Okay, then now let's move on to row 2. Row 2, column 1. So this is 1 by 5. Row 2, column 2, 1 times 3. Row 2, column 3. Okay, so you have 1 times -2. Okay, so same thing for third row. So I'm just going to quickly write down. So 2 times 5, 2, 3, and 2 times -2. Okay, so once you keep practicing, you'll get a hang of this. So this is 25, 10, 12, 3, 6, -8, -2, -4. Okay, so you should get this 3 by 3 matrix. Okay. Okay, now this last one. Okay, 2 by 2, 2 by 2. Okay, so ultimately you should get a 2 by 2 matrix. Okay, so this one again, do this and this first. So you have 3 times 2 plus 0 times 0. Okay, then do the next one over here. 3 times 1 plus 0 times -1. Then for the second row, first column, -1 times 2 plus 1 times 0. Okay, then second row, second column, -1 times 1 plus 1 times -1. Okay, then you're going to get 6, 3, -2, -2. Okay, so that's for matrix multiplication. So the key thing here is always start with writing the orders down to see whether it's possible first. Okay, and from there you can also check that your outcome matrix should be of a certain order. Okay. Okay, now let's look at some further examples. Okay, so if given these three matrices, okay, so you have this is 2 by 2, 2 by 2, 2 by 2. Okay, so basically you can do matrix multiplication to all three of this. Because 2 by 2, right? Okay, they will give you an outcome of 2 by 2 in the end. Okay, so let's do the first one first. A, B. 1 minus 1, 2, 0. Multiply 2, -1, 0, 3, 1. Okay, so one key thing over here, if it's written in this way, right? Matrix A multiplied to matrix B, write it in this way also. Okay, don't reverse the order. Okay, so remember for matrix addition, you can do that. But for multiplication, matrix multiplication, don't do that. Okay, so here for matrix multiplication, okay, A matrix A multiplied to B is not the same as B multiplied to A. Okay, so here, okay, let's continue with this. So again, should be quite familiar already by now. Okay, so this entry 1. Okay, so this should be a 2 by 2 matrix first. So entry 1 over here is your row 1, column 1. Okay, so 1 times -1 plus 2 times 0. Okay, then you will have this and this now. So 1 times 3 plus 2 times 1. Okay, then I'm just going to quickly fill in the rest also. So -1 times -1 plus 0 times 0. -1 times 3 plus 0 times 1. Okay, then you should have -1, 1, 5, and -3. Okay, so this is still basic. Okay, here. Okay, when you see a square over here for matrix multiplication, right? It doesn't mean squaring of the values inside, okay? Okay, so key thing to take note of here, write this down. Do not square each of the elements in matrix A. Okay, so in matrices, right? In matrices, we only do matrix multiplication. Okay, so when you have A squared, it basically means matrix A multiplied to matrix A. Okay, not squaring of the values inside. Okay, so there's no such thing as squaring of the values inside in matrix multiplication. Okay. Okay, so when you deal with powers or squares, cubes, or whatever, right, you can only do matrix multiplication. Okay, meaning this should be A multiplied to A, matrix A multiplied to matrix A. Okay, so take this down. Okay, so in this case, if we're going to find A squared minus C, this is the same as A minus C. Okay, so if A is a 2 by 2 matrix, A is also 2 by 2, then this would be a 2 by 2 matrix. Okay, so when you do subtraction, again, they should be of the same order, right? So this is 2 by 2 also. So therefore, you can do that. Okay, so these operations are possible. Okay, so first, write it down, your A minus C. Okay, so do the left side first, your matrix multiplication. This part over here first. Okay, so you should have 1 times 1 plus 2 times negative 1. 1 times 2 plus 2 times 0. Negative 1 times 1 plus 0 times negative 1. Negative 1 times 2 plus 0 times 0. Okay, then minus 4, 1, 0, negative 2. Okay, then this will simplify to negative 1, negative 1, 2, negative 2. Okay, minus 4, 1, 0, negative 2. Okay, then this will give you the outcome of negative 5, negative 2, 2, and 0. Okay, so a 2 by 2 matrix. Okay, now what if we have to now deal with matrix multiplication involving 3 matrices? Okay, first check out. Okay, just nice this example, right? They are all 2 by 2 matrix. Okay, so of course you can do matrix multiplication with them. Okay, because A multiplied to B will give you a 2 by 2, right? Then multiply to C, which is also a 2 by 2. So the ultimate outcome will be a 2 by 2. Okay, so now let's write it down. A, B, C. 1, negative 1, 2, 0. Negative 1, 0, 3, and 1. 4, 1, 0, negative 2. Okay, so do your A multiply to B first. Okay, so you have 1 times negative 1 plus 2 times 0. 1 times 3 plus 2 times 1. Negative 1 times negative 1 plus 0 times 0. Negative 1 times 3 plus 0 times 1. Okay, then simplify first. You would have negative 1, 1, 5, negative 3, 4, 1, 0, negative 2. Okay, then this should give you negative 1 times 4 plus 5 times 1. 1 times 4 plus negative 3 times 1. Negative 1 times 0 plus 5 times negative 2. 1 times 0 plus negative 3 times negative 2. Okay, then this will then finally give you 1, 1, negative 10, and 6. Okay. So matrix multiplication, just have to be very careful. Okay, just remember your final outcome should come from this combination. Okay. Okay, now let's move on to another example over here. Okay, here, this is a mixture of addition of matrices, scalar multiplication of matrices, and also normal matrix multiplication. Okay, so this is the matrix multiplication, scalar multiplication, and then you have addition also. Okay, so let's check first. Your B is a 2 by 2 matrix. Okay, so when you have B multiplied to B, right, this should also give you a 2 by 2 matrix. Okay, then this is scalar multiplication. So this will just follow your order of B. Okay, so this P multiplied to B, right? This is also a 2 by 2. Okay, so same thing for this. Your identity matrix, right, in this case, because it is addition of matrices, so for it to be added to this 2, right, this should also be a 2 by 2. Okay, and then lastly this. Okay, this one over here, if you see a 0 that is bolded, right, this doesn't mean this equals to 0. This is 0 matrix, okay, or you call it null matrix. So in this case, right, since everything is 2 by 2, right, so this should also be a 2 by 2 0 matrix. Okay. Okay, so now let's write out everything in matrix form. So your B square will be 2, negative 1, 3, 1, multiplied to 2, negative 1, 3, and 1. Okay, then you have P times of B. Okay, plus Q times of, okay, in this case, your identity matrix, right, would be a square matrix where the leading diagonal entries are 1. Okay, so this is a 2 by 2 square matrix. So it will be 1, 0, 0, 1. Okay, equals to a 2 by 2 0 matrix. Okay, where all the elements are 0. Okay, so once you have this, okay, let's try to solve for this. Okay, so always start with matrix multiplication first. Okay, so over here, you would have 2 times 2 plus 3 times negative 1. 2 times 3 plus 3 times 1. Negative 1 times 2 plus 1 times negative 1. Negative 1 times 3 plus 1 times 1. Okay, then for scalar multiplication, right, you're just simply going to multiply p into each of the elements. Okay, so this is going to be 2p, 3p, negative p, and p. Okay, then similarly for the scalar multiplication of q to the identity matrix. So this is going to be q, 0, 0, q. Okay, then you're going to get this. Okay, now slowly simplify the matrix multiplication first. Okay, so this is going to give you 1, negative 3, 9, negative 2. Okay, plus 2p, negative p, 3p, plus q, 0, 0, q equals to 0, 0, 0, 0. Okay, now once you reach this stage, right, where it's all addition, okay, now you're just going to add each of the corresponding rows and columns. Okay, so for your first row, first column, it's going to be 1 plus 2p plus q. Okay, 1 plus 2p plus q. Okay, then for the first row, second column, 9 plus 3p plus 0. Okay, then for second row, first column, you have negative 3 minus p plus 0. Okay, for the second row, second column, you have negative 2 plus p plus q. Okay, then this is equals to 0, 0, 0, 0. Okay, so over here, when you have a matrix equals to another matrix, okay, then you're going to compare each of the entries directly. Yeah. Okay, so to find the values of P and Q, okay, first of all, the easiest, right, is to start off with this, when there's only one unknown P. Okay, so from row 2, column 1, okay, you can see that negative 3 minus P equals to 0. Okay, so therefore P should be equals to negative 3. Okay, then now once you solve for this, right, you can try to solve for Q also. Okay, so let's say if we look at row 2, column 2. Okay, so from row 2, column 2, you have negative 2 plus P plus Q equals to 0. Okay, then you have found P is negative 3, right? So negative 2 minus 3 plus Q equals to 0. So therefore, your Q should be 5. Okay. Okay, so that's all we have for this question. Okay, now let's move on to this one over here. Okay, this other example. Okay, so if you are given the matrix A and B, you want to find the values of X and Y given that A, B equals to this matrix. Okay, so basically you're going to equate them and then compare directly. Okay, so first A, B equals to X negative 5, 9, negative Y. Okay, so sub in your A and B as your matrix multiplication. Okay, so by now you should be quite familiar with matrix multiplication already. Okay, so now I'm just going to quickly do. Okay, so over here, you're going to look at this and this first, right? Okay, so this is going to give you 2 times 1 plus -1 times -2, which is 4. Okay, then first row, second column. Okay, this is going to give you 9. Okay, then now when you deal with second row, first column. Okay, this is going to give you -5. Okay, then second row, last column. Okay, second row, second column. This is going to give you 1. Okay, equals to x -5, 9 -y. Okay, so now a matrix equals to another matrix, compare directly. Okay, so here you have it already. Okay, so x equals to 4. And then where's your unknown y? This part over here, right? Okay, so you have 1 equals to -y, so therefore y should be equals to -1. Okay, so that's for part A. Okay, then for part B, you are given 2a plus c equals to b plus I. Okay, then you're supposed to find matrix C. Okay, so first let's try to sub in first. Okay, so this is 2a plus c equals to b plus I. Okay, your I is your identity matrix. Okay, so again, now here is addition, right? Okay, so here, first thing, this is a scalar multiplication. Okay, then the rest are all addition of matrices. Okay, so let's write it down first. So you have 2 times of 2, 1, -1, 3. Okay, plus c, which you don't know. And then you have b, which is 1, -2, 4, and -1. Okay, then plus identity matrix. Okay, here this identity matrix, right, must be a 2 by 2 identity matrix. Okay, because you are adding to this matrix, right? So it must be of the same order. Okay, so therefore this would be 1, 0, 0, 1. Okay, now let's try to simplify first with the scalar multiplication here, which is 4, 2, -2, 6 plus c, which is, okay, then simplify this addition over here, which is 2 minus 2, 4, and 0. Okay, then matrices, right? Okay, so you can do it like how you would do for equations of numbers or algebra. Okay, so just shift this over to the other side. Okay, so you're going to minus this. Okay, so 2, -2, 4, 0, minus 4, 2, -2, 6. Okay, so you can only shift it like that when it's addition or subtraction for equations involving matrices. If it's multiplication, right? Let's say if A, B equals to C, right? There's no such thing as B equals to C divided by A. Okay, we would not touch on division of matrices. There's no such thing. Okay, so this is a wrong concept. Okay, so this only applies for addition and subtraction. Okay, so here you will then have -2, -4, 6, and -6. Okay. Okay, so these are so far what we have for all our operations involving matrices. Okay, so we have touched on addition, subtraction, scalar multiplication, and matrix multiplication. Okay, so that's all we have for this section.